Hey, what's up, guys? This is Cheng here again. Today's daily challenge problem, number 795, number of subarrays with bounded maximum. So this one is a pretty interesting problem. At the first glance, I thought this one was just like you know um, sliding window problem, but this one turns out to be a little bit different. Okay, so you're given like an array nums of positive integers and two positive integers, basically the boundaries, right? The left bound and the right bound. And you need to return the number of the subarrays, right? Such that the value of the maximum array element in that subarray is at least is basically between this range. Right. So this one it doesn't ask you to return the longest subarray or something like that. Instead, this one is asking you to count the total subarrays, right, who satisfy this condition, right? So this one is a little bit different. So it's more like a counting problem instead of like a sliding window problem, right? Because if this one is asking you to find the maximum or the smallest subarray, obviously not obviously, most likely it's going to be a sliding window problem, right? But this one, it's a counting problem instead. So the approach will be different here, right? So for example, we have this one, right? And so it's 2, 1, 4, 3, right? So the answer is 3 because we have in total we have 3 subarrays whose maximum is between the 2 and 3, right? So we only have this 3 subarrays. That's why the answer is 3. Okay, and yeah, so some basic constraints, right? 50,000, something like that. Actually, this one is 50,000. Yeah. Okay, cool. So since this one is a counting problem, let's start with the base case, right? Assuming if there's no right left or right? So how does counting work, right? So if we have this kind of some numbers here, right? If there's no constraints here, so the total number of a substring, sorry, a subarray is what? Basically, it's the length. It's basically, let's say we have an answer, right? So at the first place, the answer will be 1, right? So and when we move to the second one, the basically we're accumulating, we're adding 2 more, right? Because we're adding this number here. Actually, is the what? Is this a number plus the previous one? That's why we have 2, right? And then we move to here, right? We need to add 3 because by including this one, we're including 3 more subarrays, right? Basically, this one, this one, this one, and this one, right? So so on and so forth, right? It's plus 4, plus 5, plus 6, right? Actually, this is how we calculate the total subarrays given like array here, right? So this is the base case without these constraints. But this one, actually, this problem, it's giving us 2 constraints. So which means that we should only count the subarrays, right, whose maximum is within this range. Okay, right? And how can we do it, right? So I think the best way of solving it is by trying to find a good example, right? Um, let's say, okay, so let's do a little bit of modification for this one. Let's still use left equals to 2 and right equals to 3, right? So let's go with this one, 2 and 3. Okay. So the first one is 2, right? That's why we have answer equals to 1, right? And then the second one is 3, right? So based on our previous base case, we do a plus 2 here, right? Because both 2 and 3, both 2 and 3 are in the range here. That's why we can add 2 here, right? So let's say the last one, the next one, instead of 2 or 3 is 1. Okay. So this one is not in the range of left or right. right? So basically, whenever there are two cases, right? Since we have this range, we have a left and right and right. So there are two cases is that, if number is smaller than the left, is here, or this number is bigger than right, it's on the right side. That's a two special case we need to handle here, right? So let's say we have a 1 here. So 1 is smaller than it's left. So if we have 1 here, so what's this question mark here, right? Obviously it it cannot be 3, right? Because 1 itself is not the it's not within the range. That's why we cannot add 3. So what's the number we should add here? It's still 2, right? Because with 1 here, the new 2 subarray we have here is like is this one and this one, right? Because 1 is not itself, right? So that's why we have 2 here. And so how about, so the next one, if the next one is another 3, right? So what's this gonna add here? So now the 3 is also is within the range, right? So how many we have here? This one, as you guys can see, we're gonna add 4 here, right? Because this count actually is the total new array ending with the new number here, right? Because 3 is within the range, so which means that now we have this 3. Remember, left and right is 2 and 3, right? And then we have this one and this one and this one, right? So that's that. And how about next one is another special case. Let's say we have a 5 here. So what does 5 mean? 5 means that, okay, 5 is greater than the right. So it means that nothing can include 5 in starting from here, right? Basically, if we see a number which is greater than right, it means that we have to start everything again. Basically, this one is gone, right? We have already accumulated everything there, right? That's the result. When we see a greater number here, basically this one's going to be 0, right? And then we have to reset everything starting after 5, right? Let's say we have another 2, 3, 1, 3 after 5, right? So this one is going to be 1 plus 2 plus 2 plus 4, right? So that's how we do the calculation. And now, as you guys can see, so in order for us to calculate this number here, we need to what? We need to keep like the starting point of this kind of valid subarray, which is the index here, right? And every time uh, when the current number is smaller than left, so we still use the previous length, which is 2, right? And when the current number is within the range, right? So basically we update. Basically we'll use the new length, which is the current index, the current one, subtract the previous one, right? That's why we get 4, and that's why we get 2 and 1. And lastly, when we see a greater number, like a number who is greater than right, then we know, okay, it's time to reset everything. Basically, we're gonna reset this pre to this one, right? And then we start everything all over again. Cool. So I think that's the whole idea. As you guys can see, this one is not that easy as it seems to be at the first glance. But once you figure this out, the implementation is super short. Okay. So then let's do it. So for me, we have answer, and then I have a count. So the count will be 0, and then I will pre equals to -1, right? And then for I dot number in enumerate numbers. So the reason that I put a -1 here is because if the first one is is also within the range, then in the end I'll be using the current index minus the previous one. I don't do a +1. That's why I need to use -1 so that when the 2 is within the falls in the range here, if I use 0 minus the previous one, I will get 1 instead of 0. That's why I use -1. Okay. So two cases, right? So if the left is this is the happy path, right? So if this number is within the range, then we know the count will be I minus pre, right? And because in the end we'll be accumulating this count. Yeah, actually, no, actually we don't even need that. We don't even need we don't even need this count. Actually, it could be something like this. Could be this is all we need, right? So if that's the case, we simply do a answer dot this, right? Else if the number is greater than the right? If this one is the case, then we set the pre equals to I, right? And then I think we still need to count because if the number is smaller than the left, then we'll be using the previous count, right? Which is okay, I see. Okay, then let's maintain this count anyway, right? So we have a count equals to that, and the pre. So okay, so whenever the number is greater than right, then we reset this pre, right, to the current index, and then we also reset the count equal to 0 because, like I said, we're starting all over again, right? And then in the end, we do answer dot this count. We accumulate this count into the final answer. Then we return the answer. Right here, actually, there's like a hidden case here. Not hidden, but basically if the number is smaller than left, right? So this is the third case. But for this one, if that's the case, we don't need to do anything. Actually, that's like I said, we will in this case we'll simply just use the previous count to accumulate to the final answer, right? For the case of 2, 3, and 1, right? So this is this case, and then but the count is still 2, right? That's why we have 1 plus 2 plus 2. Cool. Yeah, I think that's it, right? So that's as simple as it is. If I run the code here. Okay, accepted, right? Let's run it. Cool. Yeah, I think that's it, right? Pretty straightforward. O of n time complexity and O of 1 space complexity, right? Yeah, I think that's it, right? I mean, so this one is like a counting problem instead of sliding window problem, and so we use few helper like intermediate helper like state like count and previous one to help us to find the range or right and also the number we need to accumulate to the final answer. Uh, that's it. Okay, cool. Let me know what you guys think, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.